Hey guys, in this video we are going to find the area of a rhombus and a kite. The area of a rhombus is half the product of its diagonals. Okay, so that means the area is 1/2 times diagonal 1 times diagonal 2. The area of a kite is also half the product of its diagonals. So the area of a kite is 1/2 diagonal 1 times diagonal 2. So here we have an inlay on the neck of a guitar, and that inlay is in the shape of a rhombus, and I know it's a rhombus because this right here, this blown up picture of one of the inlays, has 4 congruent sides. So we want to find the area of that inlay. So the area is 1/2 times diagonal 1 times diagonal 2. It doesn't matter which diagonal is 1 and which is 2. This 12 millimeters is this right here. There's another 12 over here. So that diagonal would have a total length of 24. Okay, now this diagonal is 9 plus 9. So that is 18. So we have 1/2 times 24 times 18. And that is 216. So we get 216 millimeters squared. Next we have a figure with a pair of congruent sides next to each other and then a different pair of congruent sides next to each other. That is a kite. The area of a kite is 1/2 times diagonal 1 times diagonal 2. This 14 goes all the way from end to end on this kite, so 14 is one diagonal, and 6 connects these two vertices, so that is another diagonal. So 1/2 times 14 times 6. And that is 42. So the area is 42 inches squared. Here's a rhombus, 4 congruent sides. The area is 1/2 times diagonal 1 times diagonal 2. Now this 40 only covers half the distance between these vertices, which means there's another 40 here, so that diagonal is 80. This diagonal is 30, but that only covers half of this diagonal. The other half is another 30. Okay, so we have 80 and 60 as our diagonals. So it's 1/2 times 80 times 60. And that is 2,400. So 2,400 meters squared is the area of that rhombus. One diagonal of a kite is twice as long as the other. The area of the kite is 72.25 square inches. What are the lengths of the diagonals? So we have a kite with diagonals, and one of those diagonals is twice as long as the other. That means if I say this shorter one is x, then that means this longer diagonal is 2x. Now I know the area is 72.25, so I've got area equals 1/2 times diagonal 1 times diagonal 2. The area is 72.25. Equals 1/2 times one of the diagonals is x, the other diagonal is 2x. Okay, now I can simplify this here. I've got 1/2 times x times 2x. I can multiply the 1/2 times 2, and that's 1, and x times x is x squared. So x squared equals 72.25. Okay, so now to get x by itself, I can take the square root of both sides to cancel out squared. So the square root of 72.25 is 8.5. So x, when I solve an equation like this, really I would get equals plus or minus 8.5, but as the length of a diagonal, the negative square root does not make sense. So it's really just 8.5. So one of the diagonals is 8.5. Okay, so that means it's either option B or C. Option B says they are both the same at 8.5. But if one of them is twice as long as the other, that doesn't make sense. Here I've got 8.5 and then 17. Now if I do times 2 here, I get 17. So my diagonals are 8.5 inches and 17 inches, option C. Okay, the area of a kite is 80 square feet. One diagonal is 4 times as long as the other. So we're doing the same type of problem here. So we've got 80 as the area. And then the area formula is half times diagonal 1 times diagonal 2. So if one of the diagonals is x, the other diagonal is 4 times x. Okay, so here I've got 80 equals half times 4 is 2, and x times x is x squared. So I'll divide both sides here by 2. So I have x squared equals 40. So when I take the square root, I'm doing the square root of 40. Now I'm going to simplify that. The square root of 40, so x is the square root of 40, and that is the same as 4 times 10. It's also 2 times 20, but I chose 4 times 10 because 4 is a square number. The square root of 4 is 2. So that means 2 comes outside. Okay, the square root of 4 is 2. Square root of 10 cannot be simplified. So 2 times the square root of 10, and that is in feet. That is one of the two diagonals. Now the other of the two diagonals has to be 4 times as long as that. So that means the other diagonal is 8 times the square root of 10 feet. So I have one diagonal at 2 times the square root of 10 feet. The other one is 4 times that long. So that's 4 times 2 is 8 times the square root of 10 feet. And last, find the area of a rhombus with these given vertices. M is 1, 3. N is 5, 5. P is 9, 3. And Q is 5, 1. Okay, so I want to know the area of that rhombus. So the area is half times diagonal 1 times diagonal 2. Now I can count these diagonals. I've got 1, 2, 3, 4, 5, 6, 7, 8. And then this diagonal is 1, 2, 3, 4. Half times 8 times 4. Now I really should be able to do this one in my head. Half of 8 is 4, times 4 is 16. So I have an area of 16 units squared.